we have moved on from clouds to what actually falls from the clouds, and that is precipitation. One of the first things that we need to look at again, because you probably looked at it before, is the water cycle. And the water cycle is the movement of water from the Earth's surface into the air and back to the surface. This water cycle is actually described in Ecclesiastes in the Bible. One incident where the Bible talks about something that would normally fall in the realm of science, that we would think would fall in that realm. And it describes it, says that all the rivers run into the sea, yet the sea is not full. Unto the places from where the rivers come, there they return again. Now, they may not have described it quite the same way, but they certainly had the idea that water falls on the land, gets collected in rivers run to the ocean, and somehow that water gets back into the sky. They may not have known exactly the process of evaporation, but they knew it got into the sky again and fell, and that there was this cycle going on. And this has created some categorizing, as a matter of fact. Scientists love to categorize. It helps us understand some things. And one of those things is precipitation. Remember, precipitation is any water that falls from the sky. And first up is liquid precipitation. We see quite a bit of this here in Oregon. Rain is technically precipitation consisting of drops of water larger than half of a millimeter in diameter, 0.5 millimeters in diameter. These are raindrops. It is the most common form of precipitation. It falls everywhere on the planet at some point, except maybe the coldest regions where it wouldn't fall as rain, but as other things that we will talk about. Snowflakes, listed there in 2 ice crystals falling down. And so, yeah, basically they have classified precipitation based off of the size of the drop. Cloud droplets are tiny, tiny, tiny. That's one of the reasons why they're suspended in the air. Drizzle, that fine little misting type rain, which I believe is actually defined on the next slide, is a little bit bigger than that, less than a half a millimeter. And then raindrops are half a millimeter or larger. Yeah, I already mentioned the snowflakes there, which is when they freeze and they're ice crystals that fall down. We'll actually talk about some different forms of ice falling here as well. And it's thought that there are basic 2 processes that form pretty much any type of precipitation, whether it's liquid or solid. And the first one up is the Bergeron process. It's thought that here clouds have temperatures below freezing that essentially make snow or sleet even. But the air at the base of the cloud is above freezing. So as the snow falls and it goes through the bottom of the cloud, it warms up enough that it melts into raindrops. That's the Bergeron process. It freezes first. This is probably more typical of high altitude where it is colder more often. And then as it falls, it turns into rain. This can explain why on a mountainside you might have snow higher up on the mountain and then rain near the base. Just those different air temperatures is enough. The other one is the collision coalescence process. This is where larger than normal condensation nuclei cause the formation of giant cloud droplets. Okay, giant is a relative term. We're talking about 0.02 to 0.2 millimeters. As these droplets drift downward, they collide with other droplets and therefore adding them to themselves and growing in size. And as our board here states, clouds with temperatures above freezing, larger than normal condensation nuclei cause the formation of giant cloud droplets. As these droplets drift downward due to gravity, they collide with smaller droplets and stick to them, growing bigger and bigger. Thus, gravity takes a stronger and stronger hold, causing them to continue drifting downward. And there we go. There's drizzle, as I mentioned earlier, liquid precipitation less than 0.5 millimeters. And then we also have an interesting phenomenon. This happens here in the Northwest quite often, and that's freezing rain. Basically, the air is so cold, or rather the ground is cold enough, but the air isn't quite cold enough to freeze them, but the ground is. And it falls as rain, but almost as soon as it hits the ground, it freezes. Black ice results from freezing rain, and icy roads in general result from freezing rain. Icicles are the cool part about freezing rain as they land on things, drippings, moving downward still a little bit. We might get some ice sickles there. But yeah, so they touch and freeze at the surface, but they're not frozen in the air. This also causes ice to form on cars and buildings and such. So really, a storm of freezing rain is frequently called an ice storm because the aftermath, everything is icy. Sidewalks, roads, everything. So it can create some tricky traveling situations. Even just wet, where it's rain, can cause tricky traveling simply because if it's been dry for long periods of time, stuff is collected on the road, and then the oil the rain kind of loosens all that up, making it very slick. I mean, water makes it slippery to begin with, so there are special tires, and people drive or should be driving a little bit more carefully when it's raining out, or if it's an ice storm where we're seeing freezing rain. And then we get to, so that's liquid precipitation, and then there's the solid precipitation. Quite a few different types here. We have sleet, and this is when raindrops freeze while they are falling. In the clouds, the air temperature of the cloud is a little bit warmer, so it actually forms as water, and then it goes through a layer of freezing air, and it freezes into a little ice pellet. Generally speaking, sleet is not very big, usually around the size of a raindrop, maybe a little bit bigger because of the collision and stuff and collecting. But yeah, these are raindrops that freeze while falling. It could potentially cause icy roads and slippery conditions. And it sounds a lot like hail because it's these hard pellets hitting stuff. So it can sound like either a really bad rainstorm or a hailstorm even, which we'll talk about hail in a few minutes here. And then there's snow, probably the most enjoyable of the solid precipitation. These are made of snowflakes falling to the ground. And there's different speeds of fall, basically. We have flurries. These are brief periods of light snowfall, resulting in little or no accumulation. We also have a snow squall, a brief but intense snowfall. So there can be quite a bit of wind involved in a snow squall as well. Heavy snowfall accumulates 4 inches or more in 12 hours or less, or accumulates 6 inches or more in 24 hours or less. That's a heavy snowfall. Now, some places at certain points of the year, Midwest, Northeast, they can get a lot of snow in a relatively short amount of time, a couple of feet in a 24-hour period. A blizzard is heavy snow, so there's a lot of snow falling, at least 4 inches in 12 or more hours, or 12 or less hours, excuse me. And winds of at least 35 miles an hour, and that contributes to blowing the snow around, not just letting it fall, but blowing it sideways, also picking up snow that's already landed on the ground and blowing it into the air. A blizzard can create a whiteout condition. And notice if the blizzard, this is if it prevails for 3 hours or more, usually is when it's called a blizzard. This can create a whiteout condition, where everything appears white, and it's impossible to distinguish between the sky and the ground when looking straight ahead. I have been in one, I'm going to call it a minor blizzard, with whiteout conditions while living in Portland. I was driving from Portland to Hillsboro, and all along the way on Highway 26, there was a lot of snowfall. Winds were keeping the snow going, and it was extremely difficult. Now, eventually, I made it home with no incident, but it was extremely difficult to tell where the road ended, where the sky began, how far ahead I could actually see, and so on, because of the snow being whipped around. Judging from stories I've heard, that is definitely not the worst blizzard that has ever happened in the world ever, so that's why I say a minor blizzard there. And hail. Now, hail is a little bit special. Hail consists of layered balls of ice forming in strong thunderstorms. And these layered balls of ice are caused primarily by strong updrafts. And some of the strong thunderstorms, it could be cold enough, it freezes, but then there are these updrafts. As the ice pellet falls, the updraft kicks it back up into the upper part of the storm, where it gets another layer of ice, it falls again, the updraft kicks it back up, and this can continue until you get baseball-sized hail. Now the picture at the bottom of the screen there is not baseball size, but that's a man's thumb and finger on it. That hailstone is probably at least 2-3 inches across there from end to edge. And the hailstone is the actual layered ball of ice. Hail is mentioned several times in the Bible. God talks about it in a few places there. And it can be fairly destructive depending on when the hailstorms fall. Usually these storms that create hail tend to be in the spring or summer. That's when we tend to get some of these worst storms. So these hailstones can be very devastating to crops that are growing. And I have heard stories before of farmers losing their entire crop or to a hailstorm because the stones were big enough and it destroyed a lot of the crop as they fell. I've seen pictures of windshields shattered on cars because of big hailstones. Because they are solid ice and they are falling from a high point. Let's see. Our book points out that the largest hailstone on record was found in 2003, had a diameter of 7 inches, but its weight could not actually be determined. The heaviest hailstone on record fell in Coffeyville, Kansas in 1970, had a diameter of only 5.7 inches, but it was almost 2 pounds heavy. It was over 1.5 pounds. And so that could fall at speeds from the height and cause serious damage. Now the other end of the spectrum. We have a picture of a sleet there in the corner. This isn't the other end yet, sorry. Sleet in the corner, hailstone, and a snowflake crystal. Now the other end, drought. When an area receives abnormally low precipitation over a relatively long period, causing a water shortage that affects crops, people, or the environment. And depending on how extensive the drought is, we might use some different terms to describe it. A meteorological drought is simply defined by comparing an area's current precipitation with the area's typical precipitation, and by analyzing how long the dry period lasts. Now, this may or may not result in a shortage of water for all of the organisms there. Now, it might be shorter than or less water than in previous years or in an average year, but that doesn't necessarily mean that plants are going to die, animals are going to go without water, people are going to need to look for different sources. It doesn't necessarily mean that. It can mean that, but this is just comparatively speaking, compared by the current precipitation to the typical precipitation. How long is this period lasting? It's just a comparison there. An agricultural drought, now this is where we see some effects. When precipitation cannot supply enough moisture to the ground to support an area's crops. Farmers are going to start losing crops in this case. So this is one where we actually see a specific effect here. The crops are not getting enough water due to lack of water in the area. Normally precipitation is what we're talking about here. And then, continuing on almost here, is a hydrological drought. Occurs when a meteorological drought affects an area's groundwater, streams, lakes, and reservoirs. So the water levels are going to go down. The groundwater is going to be lower. Wells may actually end up running dry because they may not be deep enough to go down to the lowest water during this kind of drought. Streams will go significantly smaller, even to the point where maybe fish cannot go as far upstream as they usually do to spawn. Lakes will go down in water. Reservoirs are usually man-used waters there, maybe even man-made, and it could reduce the amount of drinking water available to a population with a hydrological drought. We're noticing the effects on all the water in the area. And then a socioeconomic drought. And you may be able to tell by the name that this is going to have very little to do with what is actually occurring in nature. Meteorological drought talks about the precipitation compared from year to year. Agricultural drought, the effects of precipitation on crops specifically. Hydrological drought, the effect of precipitation in regards to groundwater, streams, lakes, and stuff. A socioeconomic drought is not based on water shortage, but based on the effects on people. Is there enough water in the area to support people? Or do people need to do something? An example would be when a city's water supply comes from a nearby reservoir, a drop in the reservoir's water level will affect the amount of water available to the city. Socioeconomic drought occurs when the supply of any material or product used by people is affected by the lack of precipitation, causing the demand for the item to be greater than the supply. So it might still be enough to supply everybody. Well, actually, no, in this case it does not. I'm sorry. I was thinking of the wrong one. The supply is actually significantly reduced, even though the average rainfall may be only slightly less. This socioeconomic drought has more to do with the people and the way a population uses the water than an agricultural drought or a hydrological drought. So that is it for precipitation. This one was relatively quick, kind of a small section here, so I will see you in class at the appropriate time. Don't forget to do the science video question so that I know that you watched this.